I want to show you another way that this alternative form of the definition of the derivative comes up because you've kind of already seen it. It was kind of a hidden problem in chapter 2, where they asked you in a situation such as the one you see here to find the value of f of 5. So I'm going to show you a sort of a different context in which this problem might appear. So let's suppose the limit as x approaches 5 of f of x minus 6 is equal to 7 thirds, of f of x minus 6 over x minus 5 is equal to 7 thirds. Now notice that what I have here, if I do substitution, is I would have 0 in the denominator. 5 minus 5 is 0. We also know is that if I have something even like 0.0001 over 0, this is equal to undefined. That just doesn't exist. You can't divide by 0. The only time that, in fact, you can't even divide 0 by 0, but at least if I get a 0 over 0 limit, then I have a hope of being able to evaluate the limit. So in this case, the very fact that this, sorry, the very fact that this limit comes out to a finite number, that we can evaluate it at all, this implies that this expression up here, f of x minus 6, has to be 0. Why? If it was anything other than 0, we would have finite number over 0, which would just give us undefined. We would know the limit was not evaluable at all. So we have to get, in order for this limit to even exist, this has to be this means that f of x minus, it means that substitution f of 5 minus 6 has to equal 0, which implies that f of 5 is equal to 6. That's just true about this sort of problem. So what we know is that if we say that f prime of 5 is equal to 7 thirds, then what can we say about the tangent line to y equals f of x at x equals 5? Well, we've just made a very good argument right here as to why f of 5 has to be equal to 6. So what that means is that whatever this function looks like, we're not given the function, but what we know is that whatever it is, f of 5 has to be equal to 6, which means the point 5,6 is on the point 5,6 is on the graph. What we also know is that f prime of 5 is equal to 7 thirds, which means the slope of the tangent line is equal to 7 thirds. So there we go. We've completely described the tangent line by its slope and by its point, giving us y minus 6 is equal to 7 thirds x minus 5. So I realize, of course, this is a little bit of a convoluted argument, but the key here is to understanding that it doesn't matter so much that this is equal to 7 thirds. What matters is that this limit exists at all and comes out to some finite number. Once it does, we know that if the denominator is 0, then the numerator also has to be 0, because that's the only way we have any hope of getting a finite number as our limit.